Okay, we're continuing with this book here, Prevent and Reverse AFib and CHF, Congestive Heart Failure by me, Pete Rogers. This is part 27. We're sort of finishing up the section on diabetes, beginning the section on stroke. You know, the book's about AFib. You can't talk about AFib without talking about stroke. I first of all just want to show how you can get cognitive decline with diabetes. One of the many ways. Diabetes, of course, damages the arteries, causing thickening of the capillary basement membrane, atherosclerosis, endothelial dysfunction, so that when you damage the arteries, you damage oxygen delivery to the tissue. So that damages your brain. That's one way diabetes damages your brain. Number two, a lot of diabetics, they're fat with sleep apnea and they're hypoxic at night. That'll damage the brain. Number three, a lot of brain cells, including your hippocampus, they have glucose type 4 transporters. Those are insulin dependent. The relevance is that people used to think the brain was not dependent on insulin. Okay, because you do have glucose type 1 transporters in the blood-brain barrier, glucose type 3 transporters in neurons that are not insulin dependent. So glucose will pass through them, all the time. However, you also have some glucose type 4 transporters on your neurons. These require insulin. So if you have insulin resistance, these will also have insulin resistance and you'll get less glucose into your brain cells. And that can decrease your cognitive function because you just can't get the glucose there fast enough. There's a little bit more to it than that. I talked about that in my previous diabetic lectures, but the bottom line is it's another problem for diabetics and cognitive function. If you talk about the stupidest patients, what patients are stupidest? There's a lot of demented patients, obviously, but just in general, what patients are the stupidest? Number one, it would be chronic kidney failure patients, like on dialysis. Almost all of them are really diminished in cognitive function. Number two, your sleep apnea patients. They're falling asleep. They can barely hold a conversation with you quite often, the more severe ones. Number three, your diabetics. They just tend to be mentally slow by the time they're, type 2 diabetes for a while. Their brains just go shh. Okay, so let's move on now to stroke. And this is stroke. So the first question I always ask people is, what's the difference between Asian atherosclerosis and Western atherosclerosis? So when I say Asian, I'm talking like a Japanese person in the 1960s. Smoking like a chimney, putting 12 to 14 grams of salt on their food, so they get hypertension from that. Okay, so hypertensive persons, isolated hypertension, they get intracranial atherosclerosis. That's what they routinely get. Typical Westerner eats a real high-fat diet, so they get Westerner atherosclerosis is most commonly, especially in the coronary arteries of the heart, but they also get a lot of internal carotid artery disease, but especially in the heart. So when you think Westerner high-fat diets, you think heart attacks. Most common cause of death in the Westerns is a heart attack. But in the Asians, eating that, it's a low-fat diet. Rice, only 1% of calories of fat, but smoking like a chimney with tons of salt. Intracranial atherosclerosis, a lot of strokes is what they have. Well, I got a little mnemonic here, ABCs. A for aorta, B for brachiocephalic artery before it branches. You can say brachio going to arm, cephalic going to head. And the head is, that's the internal carotid artery, right internal carotid artery. C for, carotid, common carotid, the left side. S for subclavian, so that's your ABC. So if you know your ABCs, you know the branch arteries of the aortic arch, okay? Here's a little anatomy of the brain. This is a side view. You call it a lateral view. A lot of it's pretty basic. You have the frontal lobe. So on the top is the superior frontal gyrus. In the middle is the middle frontal gyrus. And the bottom is the inferior frontal gyrus. Okay? And this would be the inferior frontal sulcus. So sulcus is the fluid-filled space between the gyri. Gyri is the brain tissue itself. Okay? And then the superior frontal sulcus is just above, in between the superior frontal gyrus, middle frontal gyrus. You don't need to know all this anatomy, but I'm just showing you, how it works, that it's actually a lot more simple than you think. Here's the temporal lobe, superior temporal gyrus, middle temporal gyrus, inferior temporal gyrus. That's pretty simple. It's like your fist. Let me see if I can get my fist in the picture. Your thumb is like the temporal lobe. In front of this crease right here is the frontal lobe. Behind this little crease is the parietal lobe, and where they meet in the back, that would be the occipital lobe. So just real quick, show the brain just by looking at your fist, a lateral view of the brain. That's what is relevant for our purposes at this point. Okay, some basic questions. These are questions like I always ask when I first talk to a resident or I first talk to a medical student. These are the kind of questions I always ask them. I say, I can't fix this. My screen is a little thick here. I always ask them, what is the purpose? What is the purpose of a brain? Why do animals? It was like a Voltaire question. Why do animals have brains, but plants do not? Because animals move. What is the purpose of a brain? To walk down a path in a forest, a prairie, or jungle, and to survive. So the brain is made to deal with reality. That's one of the nice things about it. The brain does not change its pronouns just because some, lefty crazy person says you now must use the pronouns that they force you to use, that they can control your language. Okay, because as soon as you start moving, you have to, like an animal moves, a plant does not. As soon as you start moving, you have to make a value judgment. I want to walk towards the fruit tree to get something to eat. There's lions and tigers and bears over there. I'm going to avoid that area. In order to walk somewhere, you have to be able to see it. You have to navigate it. You have to avoid obstacles. You have to have a memory to remember how you get back where you came from. So you need a brain. And there's even the sea squirt animal that when it's a juvenile, it swims around like a tadpole, but it's an adult phase, it attaches to a rock, becomes a filter feeder. Its brain is reabsorbed. You don't need a brain if you're just going to sit there like a filter feeder on the couch watching TV. It makes you stupid. Okay. We could talk a little bit about what's located where in the brain. The more anterior you go, the more abstract your thought, the more human and personal and unique about you is the anterior frontal lobes. Okay. The posterior occipital lobes is like primary visual cortex, especially for vision. Superior temporal gyrus, especially for hearing, auditory, okay? Post-central gyrus up in here, that's mostly for touch, kinesthetic sense, position sense, vibratory sense, okay? And right in the precentral gyrus, that's primary motor cortex to make your muscle do something. So that's a little bit of how things are organized from front to back. So the more everything in the back's more sensory in general. Frontal lobe is more motor, and all the way front is more abstract, personal thinking, what's unique about your personality. Okay, I guess I am going through the whole routine here. I don't know if I already went through the three-part brain of McLean. Reptile brain is your brainstem. You can remember that from your fist. Your fist and the little knuckles put up above, that's like your midbrain. Here's like your pons. Here's like your medulla. Here's your spinal cord, cervical spinal cord. And basically that's a reptile brain. The reptile is just an id. It wants what it wants and it wants it now. Okay, there's no thinking there like a reptile. Okay, I'm either going to have sex with it or I'm going to eat it. Okay, they lay an egg and then the thing hatches and goes out on its own. They're not very good parents. Okay, the middle part of the brain called the limbic system. Limbic means edge, but it's also called the mammal brain. Includes this gyrus right here, cingulate gyrus. It's in continuity through what's called the isthmus into the medial temporal lobe. That is the mammal brain, very impulsive, instinctual, emotional. It's like your dog, okay? And then your supratentorial brain is the human brain, the thoughtful cerebral cortex that makes value judgments, that can delay gratification, that can make you do the thing that you know you're supposed to do even though you don't want to do it. It can seek what is right for your long-term goals, self-control, executive function, all that stuff. And when you're stressed out in a major fight or flight situation, you revert to mammal mode. Okay, should I run? Should I fight? What should I do? Climb a tree? Okay. Whereas the supratentorial brain makes you think, like, okay, my girlfriend's really being a pain in the ass right now. I got a funny joke I could say, but that's kind of mean. I won't say it. It'll just piss her off. It's not worth it to piss her off over nothing. Okay, that's like your judgment. All right. Okay, now here is sort of a transverse section through the brain. If you were slicing through the brain like this, and this is at the level of what is called the basal ganglia. These are major motor centers, especially. This is a real common spot for hypertension-related strokes. I even jokingly call it stroke land. You get what are called lacunar. Lacunar means a hole. Lacunar infarcts in here. I see them all the time. Every day I see a bunch of them. The blue stuff is the cerebral spinal fluid, and that's located in the cerebral ventricles. It's also located around the periphery of the brain. That's why it's called being like a water helmet to protect the brain. These gray matter concentrations are called gray matter nuclei. GP is for globus pallidus. The orange one is putamen. The purple is thalamus, okay? So these are real common spots for having strokes. Hypertensive people get strokes in here all the time. You don't want that. They're often little strokes, but they don't help the person's cognitive function or their motor function. Here's the hippocampus, like hippocampus. What neuroscience center has the fattest students? The hippocampus. It's the memory center for declarative memory. Okay, and it's real sensitive to hypoxia and other problems. So you want to maintain good brain health, or you start damaging these neurons, and that'll damage your cognitive function. So again, the temporal lobes down below, frontal lobes are up above. These are the basal ganglia, gray matter nuclei. Gray matter is where the cell bodies are. The concentration of cell bodies is gray matter. And there's a gray matter ribbon that goes all the way around the periphery of the brain. Okay, a little bit more about brain anatomy. The outer surface of the brain is called the meninges, or like the wrapping of the brain. Okay, the little fluid that interdigitates with the cell size is called the subarachnoid space. That's where subarachnoid hemorrhages occur. Somebody ruptures an aneurysm, something. By the way, aneurysm ruptures are really rare. You want to know how often I see an aneurysm rupture? Once every 6 months. It's rare. It's really rare. Okay, and it's probably even less than once every 6 months. Most of the subarachnoid bleeds I see are small, high convexity post-traumatic bleeds. To see an aneurysm rupture, it's rare. Okay, how many strokes? I see hundreds of strokes every day. Hundreds of them. Strokes are super common. Super common. Okay, you do have lymphatics in the meninges. That's part of the glymphatic system, glial lymphatic system, how the brain cleans itself at night while you're asleep. Superior sagittal sinus are the draining veins around the brain. There's the right brain, left brain. We're not going to get into all that stuff right now. But all I can tell you is because the brain cleans itself at night while you're asleep, the lymphatic system, you are smartest right when you wake up in the morning. So whatever you have to do that's intellectual challenging, you always want to do that first thing. And one of the secrets of being a good student, a good writer, is as soon as you wake up, you sit in your desk and you start working on academic stuff. You don't take a shower, you don't eat, you don't work out. You sit in your desk and you start working because you get, in the groove, so to speak, on a roll, and you just want to keep going and in the zone. And so that's what you want to do. You want to start that as fast as possible when you wake up in the morning. If you do that, you'll be amazed how productive you are. Okay, we'll talk about this other one next time. That'll be for the next talk. We'll really go into more detail on stroke. Okay, hope you found that helpful.